Hey YouTube, what's going on? In this video, we're going to solve problem number 53 from Leetcode, maximum subarray. Let's start with the problem statement. Given an integer array, nums, find the contiguous subarray containing at least one number, which has the largest sum and return its sum. Let's take same example from Leetcode to clarify the question. Suppose you have an array with these elements. What is the maximum sum possible in the subarray? In this example, this is the maximum sum of subarray possible, which is 6. There are no other sequence in the array whose sum would be greater than 6. Easiest way to solve this problem would be to sum every possible combination of consecutive elements and store the maximum value. Let's solve this problem using this method, and after that we'll solve it again with better approach. Let's call this array nums. Let's take two variables sum and max and initialize max with first element of the array. We run the loop from 0 to n-1 where n is total number of elements in the array. We assign 0 to sum and run another loop from I to n-1. We add elements one by one to sum and check if sum is greater than max. If it is, then we change the value of max to sum. Let's do a run through of the pseudocode. First, sum has no value. Max has -2, which is the first element of the array. Then we enter the loop and value of I updates to 0. After that, sum equals 0 and in another loop j equals 0. Now value of sum updates to sum plus first element of array, that is -2. Now we check if -2 is greater than -2, which is not true. So we go for second iteration of j. J is 1 now. Sum equals -2 plus 1, which is -1. -1 is greater than -2, so max equals -1. Another iteration of j, which is 2, sum equals -1 plus -3, which is -4. Sum is not greater than max. So we go for another iteration of j, which is 3, third iteration. Sum equals -4 plus 4, which is 0. 0 is greater than -1, so we change max to 0. Another iteration of j, sum equals 0 plus -1 equals -1, which is not greater than max. So we go for another iteration of j, which is 5. Sum equals -1 plus 2 equals 1, and sum is greater than max. This time we update max to 1. So in this way we iterate for all the members of array and find the maximum. Once we are out of the inner loop, I finally updates to 1. Now we follow the same process again, but this time from second element of the array. In this way, we can find the maximum sum in the array. We can see that this code runs n factorial times, which is not an efficient way to solve this problem. There is another effective way to solve this problem, which takes only n loops. Let's write the pseudocode for that method. Let's again take two variables sum and max and initialize max with first element of an array, just like before. Now we run the loop from 0 to n-1. Like before, we add one element in each iteration of the loop to the sum. And instead of doing hit and trial and adding another nested loop, this time we add one more condition where we check if sum is less than 1 or not. If sum is less than 1, then it will never increase the overall sum. For example, say sum until any point is -2 and another element in the array is 5. Adding 5 to -2 would only decrease the total sum, right? 5 itself would be maximum than adding 5 with previous sums. So if sum is less than 1, we just reset the sum to 0. And that's it. One extra condition drops our loop from n factorial times to only n times. Let's do a run through of this pseudocode before we jump to the code. At first, sum equals 0, max equals -2, I equals 0 in first iteration, sum equals sum plus first element of the array, that is -2. -2 is not greater than -2, so we jump to another condition. minus 2 is less than 1. So we reset sum to 0. Now we move to second iteration of I. I becomes 1 now. Sum equals 1 because previous value of sum was 0. Now 1 is greater than minus 2, so we change the value of max to 1. 1 is not less than 1, so we jump to another iteration of I where I equals 2. Sum equal 1 plus minus 3 equals minus 2. Minus 2 is not greater than 1. Minus 2 is less than 1, so sum equals 0. Again, another iteration of I where I equals 3. Sum equals 0 plus 4, which is 4. 4 is greater than 1, so max changes to 4. 4 is not less than 1, so we jump to another iteration. I equals 4. Sum equals 4 minus 1, which is 3. Now sum is not greater than max because max is 4. Sum is also not less than 1. So we move to another iteration of I, which is 5. Sum equals 3 plus 2 is 5. Now 5 is greater than 4. So max equals 5. And another condition is not valid. We move to sixth iteration of I. So I equals 6. And sum equals 5 plus 1, which is 6. And again, we are going to update max because sum is greater than max. So max becomes 6. Another condition still not valid. We move to another iteration where I equals 7. Now sum equals 6 plus minus 5, which is 1. Max doesn't change because max is already 6 and sum is only 1. So another condition is still invalid because 1 is still not less than 1. So we move to another iteration of the loop where I equals 8. So sum becomes 1 plus 4, that is 5. 5 is not more than 6, so max remains as it is. And then the condition below that also doesn't satisfy because 5 is more than 1. And then we're out of loop. And we have our answer as 6. Let's write the code for the same now. This code should be able to give us maximum possible sum from the subsequence of an array. That's all for this video. Don't forget to like the video and subscribe to my channel. I'll see you guys in another video. Until then, take care.